So now we will discuss about the difficulty of problems. We will try to understand the problems basically. So why we learn something? Can someone tell me why we learn something, whatever it may be? Yes, to solve something, because to get benefit out of that by solving that problem, whatever it may be. So we have n number of problems, right, in our day-to-day daily basis, and we have n number of problems. So if you see our human history, we are solving problems from starting point of onwards. Our ancestors solved many problems and we are still doing the same thing. We are always trying to solve the problems to get something benefit out of them by solving them, right? So if we are learning something, that means we will try to utilize that knowledge somewhere so that it will benefit us. That's the reason behind, right? Anyone will learn something and they will utilize their knowledge in that field to solve some problems, right? So how many problems we solved till now as a human being? There are multiple problems solved by us, but there are many problems yet to be solved. Until unless we solve something in our day-to-day life also, we can't survive. So this, whatever I am explaining, this entire classes, right? What about data structures, algorithms? That is our core concept we are trying to learn. But I am not telling to get you certified or to pass your exam or to get job or whatever it is. Those are not reasons for you are here, because you want to learn something to give something to coming generations, right? So every time we should learn in a specific way to gain something, not only for some exams. So if you are want to pass your exam or to certify something or to get job, don't waste watching my videos. If you want to really learn something, then spend time, otherwise it will be waste of your time. I hope everyone you are here, I hope every one of you have want to learn something so that it will be helpful, or to create something by gaining some knowledge that will be helpful to other people, right? Yes. So in one fine day, one morning, you want to solve one problem. Okay, just imagine. And that problem is, you want to stop the death of a human being or species, life. So this is also one problem, right? So everything we can see it as a problem. So to resolve some health issues, you can treat it as a problem and you can try to find one solution for that, right? So just imagine you want to stop death of a life, not only human beings, any species on earth. So can we do it straight away by applying some logic or by doing some mathematics or by doing some experiments? As of now, whatever knowledge acquired by our human beings, right, till now. Whatever knowledge we have in books or in internet, whatever it can be, that knowledge is not sufficient to solve this problem. Am I right? Not only that, there are multiple problems. So, there are n number of problems we as a human being we unable to answer them, right? So just forget about these abstract things, but even we come to mathematical way of approaching to solve some problems, still we have n number of problems. Always this n makes us complicated. So there are n number of problems, even though whatever knowledge we have on maths or physics, whatever it is, we unable to solve many problems. That is the reality, right? So to solve one problem, first we will start with the problem, understanding of the problem. So the first level is, what is the difficulty of that problem? So if you doesn't know the difficulty of the problem, we may end up lot of time spending on that problem to solve. First we need to know the difficulty level of that problem, so that how much time we need to spend to solve that problem, so that we will get some proper output or expected output. But many cases, even though we spent lot of time, if you spent lot of money, if you spent lot of hours to solve one particular problem, we may end up with no output. So, while learning computers, or especially whatever we are discussing, data structures and algorithms, so once you know the difficulty level of one problem, it will be good to you how much time really I need to spend on the problem. Whether it can be solvable. If it is solvable, how much time it will take, right? So the time factor is main important one. So there are problems, simple problems like addition, multiplication, subtraction. Those are simple ones. If I ask some add two numbers, 1 plus 2, normally who knows the basic mathematics, they will say answer is 3. But even such scenarios also, if I give large number to add, it is very difficult for me. I will use calculator to add big numbers if in any case. See, that is the complexity for me. But there is a chance, there is an opportunity, there is a way, already solution given by some great people. If I doesn't know, I can search in net or I can read in book and I can apply the formulas and I will get the answer. So if even I don't know how to solve the problem, if someone knows, that means that problem can be solvable, right? So if you doesn't know, that means that problem we can't solve it. Maybe some other people, great people, solved that, so that we can utilize their formulas or methodology or algorithms to solve one particular problem, right? So if you know the difficulty level of problem, it will be good for us to estimate how much time it will take, how much resources I need to spend, how much money, whatever it is, right? So as a human being, we have a great nature to learn something, and we are strive for to solve the problems. That is our human nature. As of now, we doesn't have solutions for many problems, but maybe tomorrow or nearer future or after so many years we can solve some problems out of large amount of n number of problems. So especially, why should we solve hard problems? Whatever problems we solve, those are enough for doing some calculation, some manipulation, some analysis. But why should we solve hard problems? What is the need? Because unless we solve the hard problems, we can't utilize them properly. If you solve one problem, the problem won't restrict to the solution of that problem, won't restrict to that area. The same thing we can applicable to many of the things that can be useful for us. If you solve one puzzle or one game or one chess or one Sudoku, whatever it is, if you solve one problem, the hard problem, whatever it is, any hard problem if you solve, you are able to solve in polynomial time. Sorry, I am telling polynomial time. I will explain it later. So if you are able to solve in very with limited resources and with proper in time, then we can utilize this knowledge to solve some other problem. So everything is interlinked basically. So if you are able to solve one great game puzzle that can help us maybe in our health domain or internet domain or many cases we can apply same knowledge to others. So to solve the hard problems, it is very important. There is no waste of time. Even though there is no output, we should thankful to the people till now whoever worked and who are working to solve these problems. Even though there is no output, they are working and they are giving their lives to solve these problems. These are wonderful people are out there. They are working and they are struggling to solve these hard problems. That's why, so that we can utilize that knowledge, right? So if you take any one of the problem, normal problem, before power, light, we humans used to live in dark. But that is a problem. If you see, it is not mathematical problem or physics or whatever it is. Forget about the concepts, but it is a problem. So one of the wonderful person created, invented, found the solution so that we are using that solutions in so many places. The power is the benchmark for so many our development, human history. Telephone was created to solve one problem, but it used for some other thing. There are many inventions are born because of one problem. So the problem is very crucial here. The problem is very crucial here. How much we understand that problem, then it will lead to a good result. Right? Normally, the great people, always the successful people, even not only in scientists or business people also, what they actually do. Business people also, what they actually do. They find out the problems. That problem, based on the problem level, that means if some problem is there, because of that problem, large amount of population is suffering. If you can solve that problem, these people will get benefit, and as a businessman, as an inventor, as a finding the solution, you also get profit out of that. Not only profit, you are benefiting many lives. Not only businessman, if you are a scientist, that means your story is never ending story. You are the great person. You are giving your knowledge to solve one particular problem to generations, right? So basically, why, you can ask me why I'm telling this nonsense, because I want you to understand, before writing an algorithm or something, whatever it is, programming or language, which language or package, whatever it is, I want you to understand what is meant by problem, why we are solving it, and what is the reasons behind this, and what is our scope as a human being. Our scope is very less because our mind and our knowledge not matured enough to solve many problems. So we are limited. In limited problems also, many of us, still we are struggle to understand some problems. So don't restrict yourself to some language or some programming, maths, physics, whatever it is. Try to learn on day-to-day basis so that it will be helpful to you and it will be helpful to other generations, coming generations. That is what our ancestors done. Because of them we are alive today. Because of their inventions, because of their thoughts, because of their problem solving skills. So we should thankful to them. And to add 1 plus 2, so many of the people will do this, right? People will tell in fraction of seconds also, right? So this same function, same equation can be computed by our programming language or pseudocode, whatever. This can be achievable in very limited period of time, right? So this problem is very easy, right? Everyone knows it, because even if I doesn't know, I can calculate with calculator or something within fraction of minutes, or based on the numbers, we will get the answer immediately. There is no need to wait for that. So this is known problem and can be solvable within very less time, right? So we can say, just imagine if this is a problem, we can say this is the starting point of the difficulty. This problem difficulty is very easy. Now let's imagine, now we increased the difficulty. This is the difficulty line, just imagine. So what does this show? This is the difficulty. So this line, just imagine, if you are here, this is easy problem, and if you are going like this, go on like an axis, that means difficulty is growing. So we have some set of problems, and if I or you doesn't know, but some other people already derived and other people found the solution. So this is easy problem, and we have some set of problems. We know we can solve it in some given time, and those are already known. And if I or you doesn't know also, some other people found the solution and we can utilize them to solve those problems. So from here to here, the difficulty, from here to here, just imagine these problems can be solvable in given some time. Now let's imagine if we increase the difficulty up to here, okay, up to here, I will make this, I will erase this. So up to here. So from here to here, these problems have solutions, but from here to here these problems are harder compared to this set of problem. Okay, compared to this set of problem, this much difficulty, if I increase difficulty from here to here, this set of problem will harder to solve. Okay, now let's imagine we move to another difficulty section. Let's imagine. So now we increase the difficulty from here to here. We said these problems only we can solve, but when I increase the difficulty level from here to here, difficulty level, so these problems become harder, and now I am trying to increase the difficulty level from here to here. Now what will happen? These are more harder than this from here. When you compare this set of problems are more harder to solve the problems, right? So now normally what will happen when you say easy problems, or when you start from here, whatever the problems we can solve in polynomial time, those problems we will say this set of problems belongs to P. Okay, what is meant by polynomial time? In a previous class we saw the graphs for each functional equations, functions, like if you can solve some problem in constant time, the graph will looks like this. If you increase n, your time also increase to solve the problem. And some functions, if you increase n, the graph will looks like this, right? So if this happens, that means that problem is very harder, and that we will call it as exponential time. So from here to here, if you can solve the problem in polynomial time, n power k, if n k is some number, then those we will say P. Represent as P. So now from here to here, let's imagine from here to here, so this set is P. Now this set is exponential time. So to solve these problems we need exponential time, right? Power n, m power n. So it requires lot of time to solve the problems, and this difficulty is very high compared to this set, right? This set from here to here, what we will call it as exponential. We can solve this in exponential time period. This set we can solve it in polynomial time, whereas this set from here to here we can solve if you have some exponential time, right? So if we increase the difficulty from exponential time to something else, if we increase the difficulty, then we can find this set of problems, we can find the solution, but the time we can't determine, but we can find in some finite number of times. So we will say R. This we will represent as R. We can find the problem for this set, but we are not sure the time period, but the time period can be in some finite number. It can be 1 day, 1 month, 1 year, 5 years, 10 years, whatever it means, but these problems can be solvable from this point to this point in given finite number of times. So we will represent this set of problems as R. So now the big question comes. After this difficulty, if you are increasing the difficulty level, these problems can't be solvable as of now. So even though we have lot of money, lot of efforts, man hours, lot of time also, these problems can't be solvable. See, that means what? Our scope as a human being is this much, right? From here to here. Whatever the problems are in this margin, those problems only we can solve. But there are outside of this boundary, there are multiple problems we are unable to solve as of now. So the problems can be solvable in polynomial time, n power k, that is this part. The problems that will be solvable in exponential time, power n, so those problems can be solvable in exponential time. If you give some finite number of time, that problems can be solvable in this set. So if you see, the level of difficulty also will increase from here to here, here to here, here to here compared to. So వెళ్ళమ్మా నువ్వు ఇలా మాట్లాడితే నాకు So this is polynomial, this is exponential, this is R. Now see, this is very hard. From here, the point, these are the hardest problems will come to in front of you if you increase the difficulty level. Okay, but the people are there. People are still working on to solve these problems from polynomial edge to at least exponential, and they are trying actually. They are trying to find the solutions for the problems which are harder. If they are succeed, then as a human being we also succeed. As of now they are trying, and now we learned, and now we know what are the problems can be solvable in polynomial term that are easy. That means we have the solutions for those problems. Whatever in exponential time, exponential problems, there are no direct way of solutions. If you goes here, this is, you need finite number of time, but this is very much harder compared to exponential time. If you go beyond R, those are unsolvable problems. Okay. So if you just want for your understanding, exponential time problems like chess, Sudoku, these are all need exponential time, power n time to solve these problems. Just imagine we have chess, 8 columns, 8 rows, 200 by 100 matrix, 1000 by 1000 matrix, and 1 lakh by 1 lakh matrix. What will happen? At least to solve the queen problem itself, to place queen in 8 by 8 chess board, it will take some time. It is hard problem basically. But if you increase the n, what will happen? To calculate all the steps in chess, it requires lot of efforts, lot of computational resources, lot of time. It is definitely an exponential time, because when we increase the n, then that much harder it will become. When you increase the n, the same amount, the time to solve that problem also, it will take exponentially. Now we understand the difficulty level. If the difficulty level grows, the time we need to spend on to solve also will grow same way. And for something, even though we spent lot of time, there are no answers. So now the interesting point is, this from here to here, this is polynomial time. So from here to here, this edge to this edge, these are harder problems because we know this falls under exponential time, right? So here also we can, if I draw some line in between these, we can say these problems can be categorized as NP. So what we done, in between P and XP, I drawn some difficulty and I am making them as one category into NP. NP means non-deterministic polynomial time. That means from here to here, the set of problems can be solvable. Just try to understand. From here to here, the problems can be solvable in polynomial time. If there is a lucky kind of mechanism, lucky kind of device, lucky kind of algorithm, something is there at your side as lucky, what it will do is, whenever you struck, if you ask that device or ask that lucky algorithm, it will give you the proper answer. Okay, we will discuss more on this. See, from here to here, we are calling them as NP, non-deterministic problems, because we know this set, polynomial time set, we know defined steps to solve any particular problem in this set. But whereas here, what we are saying is, we are not sure about the steps, but just assume we have one lucky algorithm, we have one device, someone created one device that makes or that gives you the result at any point of time always yes. So this, whatever we are calling as lucky or the angel, that device or that algorithm or book, whatever it is, we will call it as lucky. That lucky always will gives you the proper answer, irrespective of the problem. So there is no deterministic way, but we are relying on some lucky. We are relying on some luck. Based on that luck, we can solve these problems. But the problem comes here. If I know how to program luck, if you know how to program luck, if I know how to create luck from a device, that will be good. So if I know how to create luck from device or program algorithm, that will be good. But in reality, is it possible? Can we create luck by creating some device? No. As of now, no. We can't program luck. We can't automate luck, right? We can't create luck. So, but we believe if we have some such kind of device, such kind of algorithm, we can solve these problems. That is what the idea behind this. This is we will call as NP set, non-deterministic polynomial. What does this mean? These set of problems can be solvable in polynomial time. That is our main goal, right? Main goal is we want to solve all these problems in this. We want to push all these problems into this set. We want to solve all the problems in given time instead of waiting for long time. That is our human beings idea. But to solve some problems, harder problems, we doesn't know how to solve. That's the reason what we are saying. Just imagine from here to here, the set of problems can be solvable in polynomial time if there is one luck device or one luck programming. What exactly that will do, luck programming? It will guess and give you the answer based on your input. That is what meant by non-deterministic polynomial algorithms, right? But in reality, we can't engineer, we can't create one device for luck, right? Actually, there is an argument from many years. People argues P equals to NP. That means this set, whatever set we are calling as from here to here, some people believes these also comes under this. And some people believes, majority of the people believes NP is not equals to NP. That means these are not in same set. Some people, very few people believes this set and this set are equal, but majority of the people doesn't agree with that. This is an argument still we have. This is a big problem. If you can solve, you will get lot of money. So now, based on the difficulty, we understand what are meant by what is our problem, right? So another way of representing NP, non-deterministic polynomial, majority of the problems are like decision problems. That decision problems means I will give an input to that problem algorithm, and that algorithm will give me yes or no as a Boolean values. So the decision problem solutions can be checked in polynomial time. Okay, in polynomial time. So that is another way of representing the problem here also. What we are saying, for decision problems, for given solution, that can be checked whether it is right or not in polynomial time. But checking of a solution, checking of an answer is very easy compared to finding a solution, right? So that's the reason many people doesn't believe P is not equals to NP, but few people still believes P equals to NP, right? So there are two reasons. The people who doesn't believe P not equals to NP, because we can't program luck, we can't automate luck, we can't create a device to create luck, and it is very easy to check the solution instead of creating a solution, finding a solution. Always finding a solution is harder than checking a solution, checking the answer. So now, I hope every one of you understood what is the importance of difficulty and what are these words, each words represents. So now we have another two words I want to discuss now itself so that we won't confuse. So this set is P, polynomial time. This set is NP, non-deterministic polynomial time. This set is exponential time requires. This set is some finite time to solve the problems. So the problems, let's imagine from here to here, all the problems are harder, right? From here, once you cross this line, all problems are harder, right? So if any problems resides here, this is a harder problem. When any problems resides here, this is also harder problem. So problem ఏం చేస్తున్నా? So from here, this set to this set is NP hard problems. So once you cross this line, NP line, remaining all things are very NP hard problems. Once you cross this line, exponential, these are XP hard problems. So that means we crossed that limit. And this line and this line represents, I will write here, NP complete, and this mark represents XP complete problem. So I hope everyone understand this NP hard. Once from here to here, so on, all are NP hard problems. We can say once you cross this limit, the difficulty level, we will say all are XP hard. And when something lies here, we will say NP complete. So when we say one problem is NP complete, means the problem should be, whatever the problem we are calling as NP complete, that problem should be as much hard as other problems. That means this problem is hard, same as any problem in this set. That is one criteria. And this problem should reside in between these limits. Then we will call it as NP complete. So that means we assume if we can solve one problem, we can solve other problems also by using same mechanism. So I hope every one of you understood this line. This is for our understanding purpose. We use this line basically. Let's imagine, I am just repeating quickly. If this is a level, represents the level of difficulty, and we will mark this as polynomial time. Whatever the problems can be solved, we will make them as polynomial time. And whatever the problems can be solvable using luck algorithms, those things we can mark it as NP problems. And those problems require exponential time, we are marking them as exponential problems. And those problems can be solvable in finite time or recursive. Those problems we are marking here. After that, those problems can't be solvable, right? Okay, now let's imagine I have a box. Just imagine this box represents all the problems in the world, whatever we know. Just imagine this box represents all the problems, whatever we know. Okay. So this box represents the problems. Now this P, this is circle P, represents the problems that are solvable in polynomial time, n power k. K is some number. Okay, so after that what we have? Exponential time. So this set represents exponential time problems. So because this is subset of exponential time, right? Okay, so here we have some set that will some problems we will consider them as NP, non-deterministic polynomial time problems. And after that, if we given some infinite number of time, we can solve some problems. Remaining all these problems are, as of now, we doesn't know how to find the problem, even though we have lot of time and lot of manpower, lot of money. Maybe in future we may expand, but the idea behind this is we always, if this is P, if this is XP, if this is R, so this is polynomial time problems that can be solvable in polynomial time. This circle represents exponential time problems. This circle represents R. So the idea behind is always what is our target? We are targeting to pull all these problems into this polynomial section. That is what our idea. We want to make this circle as big as remaining things. So that means what is our idea? We want to solve exponential time problems or R time problems into polynomial time problems. We want to solve all the problems, all these problems, we want to make them as to solve in polynomial time problems, so that we will find the solutions and we can utilize it in our real world scenarios. That is what the behind scenes actually, that is our motive, right? So our motive is to solve all these problems to become as P. So we want to make this circle as to occupy this complete section. We want to make this total all problems as P. We want to solve all these problems as P. That is what our idea. Okay, I hope everyone understood.